Alright guys, so we've got an SAT test score here, and it says the mean is 1100, the standard deviation is 160, and the scores are normally distributed. So I'm going to ask you a bunch of questions. Number one, what percentage of students should score below 790? And so the first thing we're going to do is find a z-score. Remember, z-score is always equal to x minus x bar over S, or x minus mu over sigma, depending on if we're talking about a sample or a population. In this case, we're talking about a population. So z, in our case, is going to be 790 minus 1100 over 160. Okay? So I'm going to take my handy-dandy calculator here, and I'm going to say 790 minus 1100 and divide that by 160, and I get a big long decimal. I get negative 1.9375. But we're going to round that to negative 1.94 because all of our tables are to 2 decimal places. Okay? Then I'm going to go to my table, find my negative z-scores, and I'm looking for negative 1.9. I'm going to read over to the 4 column here, and I get 0.0262. Okay? So that gives me an area of 0.0262. Now they ask me for a percentage, so that is going to equal 2.62%. That area under the curve is a decimal. We're going to convert it to a percentage. Okay? Number 2, what percentage of students should score greater than or equal to 1400? Okay, so if our area under the curve is everything left of a point, then everything equal to or right of will be 1 minus. So again, we're going to start with a z-score, and our z-score is going to be 1400 minus 1100 over 160. Now in this case, I'm going to go ahead and round it for you. This is going to give me 1.88. It's going to give me 1.88. If I go to my table, let's go to my table here, positive z-scores, 1.8, and we're going to go all the way over to the 8 column. 1.88 is 9699. 0.9699, but that is the area to the left of this score. I need to go what? 1 minus 0.9699, and that is equal to 0.0301. This is the area at and above this score, and so we would say this is going to give us what? 3.01%. We expect about 3% of applicants to score equal to or greater than 1400. Okay? All right. What's the probability that someone scores below 700? Okay, so again, we'll find. Nope. Sorry guys, my camera cut out on me there for just a second. What is the probability that a student scores below 700? I went ahead and found the z-score here. It is negative 2.5. We go to our z-table here. We go to our normal distribution. Okay, and we're looking for that negative 2.5. It's 2.50. 0.0062 is the area. Okay, and since we're asking if the probability that they score below that, we're going to use that area right out of the table, 0.0062. Now remember, the area under the curve is probability. So if I ask you a probability question about a normally distributed population, if you can read this table, that is the probability someone scores below 700 on this test. Okay. Next question, what percentile is a score of 1200? We covered this earlier in the book. It was how to find percentiles, and it's quite difficult to do. With a normally distributed population, it is not. Let me find it for you. So guess what we're going to do? We're going to find a z-score. 1200 minus 1100 over 160. So let's calculate that. 1200 minus 1100 over 160 gives me 0.625. And we're going to call that 0.63 because our z-score table is only rounded to 2 places. So we're going to go to 0.63. So here's 0.6. And we go over to the 3 column. So 0.63 has an area of 7357. 7357. So I'm going to go, that is an area of 0.7357. Another way to think about that is 73.57% is below 1200. Now, if I told you we're going to basically call this what? It's basically 74%. If I told you 74% of data was below this score, then you would tell me that this is the 74th percentile. And that is actually pretty easy to find. Okay. Next up, what percentage of students do we expect to score between 1440 and 1360? 1440 and 1360. Now, I am going to cheat just a little bit. Okay. No, I'm not. I lied. I thought I found this one earlier. So what are we going to do? We're going to find a z-score for 1440. And we're going to find a z-score for 1360. Okay, so let's find both of those. So 1440 minus 1100 over 160 is a z-score of 2 point, and I'm going to round this 13, 2.13. And then this guy here, if I say 1360 minus 1100 divided by 160, I get 1.63. Okay, now what do I need to do? I need to find those areas. So I'm going to find 2.13 is here. 2.13 is here, 9834. Okay, so it's going to be 0.9834 minus, and then we're going to find our 1.63 area, 9484. 9484. Always the bigger one minus the smaller one. And so if I say 0.9834 minus 0.9484, I get 0.0350. Okay, now that's the area. They ask me for a percentage, so we have to turn that area, so that's an area. Percentage would be what? 3.5%. Okay, so we're just moving that decimal. That's all we're doing, just moving that decimal. Come on, paper, move. Doesn't want to move for me, y'all. Okay. All right, last one. What range of scores would be expected on a given test day? I.e., what range of scores would be considered likely on a test day? Well, remember, we have the good old 5% rule. Anything that is less than 5% likely is considered unlikely. Now, you've got a couple of ways of doing this, but the easiest way of doing this is that we expect it to be likely for 95% of our population and unlikely for 5% of our population. And so what we're going to do is we're going to look at this and we're going to say, basically, look, we're going to find the mean plus 2 standard deviations and we're going to find the mean minus 2 standard deviations. Okay? And in our case, that's going to be 1100 plus, that's why you should write in pencil, not pen, plus 2 times 160, and 1100 minus 2 times 160. Okay? And that is going to give us 95% of the population, and it's going to knock out that 5%. So here goes. 1100 plus 2 times 160 is 1420. And 1100 minus 2 times 160 is going to be 780. Okay? And that is the range of scores we would expect on a given test day, 1420 to 780. Okay? It would be unlikely for someone to score outside of that range given these particular parameters. Okay? So anyway, those are your notes for Chapter 7. Please take those notes, get your homework done, and email me if you have questions. Remember, your completion of this assignment is your attendance for the day that I'm out. Best of luck, guys. Let me know if you have any questions.